Okay, you'll have already read the question and attempted it at home, so let's just have a look at the answers. So state the test, including the result for hydrogen gas, right? So you're not having to answer too many questions about this particular reaction just yet. You're just answering some practical questions. And what's the test for hydrogen gas? Well, the answer they require in the answer sheet is burns with a pop. Okay, you could say introduce a lit splint to the opening of the test tube and the hydrogen gas will combust with oxygen with a popping sound. Right, that's what I wrote in there originally. It's more than you need. It just burns with a pop. The reason it burns with a pop is because the hydrogen gas, the oxygen gas are converted into water. So there's a massive volume change in a very, very tiny amount of time, and the air rushes in to replace the gas and makes a popping sound. Okay, so that's the way it works, an implosion rather than an explosion. Right, student was asked to draw a diagram. So again, we're just a practical thing. This is how you write up your notes and how you write up your practicals. And in this part of the question, we had to say what was wrong with the student's diagram. Now, you might have spotted a couple of things, and the best thing to do is just go for the obvious ones. There's two obvious ones, right, that are here. One is you need a bung here. There's no bung on this flask. Now, you could say bung or stopper or cork. Those are all fine. The flask wasn't labelled, by the way, and they did allow to say the measuring cylinder wasn't labelled, so presumably they accept the flask wasn't labelled as well. But those are minor. Go for the obvious one. Don't choose something obscure. You're not winning any points for being clever. Okay, so no bung, no stopper or cork, or the collecting tube is blocked, or the delivery tube is blocked at the end, not allowing the gas. You must show a clear path for the gas to come out. The other marks they allowed was there was no scale drawn on the measuring cylinder. It's not necessary. It's actually kind of you don't have to draw a scale in the measuring cylinder, really. But anybody who spotted that there was no scale there got the mark. And the measuring cylinder wasn't labelled, which again isn't necessary because it's clearly a diagram of a measuring cylinder. So that got the mark if you said that. It didn't say anything about getting the mark for not saying this was a flask, but there you go. Let's move on to part 3 of this question. So these are all practical questions, and again, this time we had to collect a dry sample of the zinc sulfate, which is is in solution. It's dissolved. So obviously, what we need to do is get a clean version of this solution. So I said filter the products, then evaporate. That you don't have to put in filter products. But the zinc powder, I think, is there in excess, so you'd have to filter it out. Otherwise, it would be mixed in with your zinc 2 sulfate. But it doesn't say obtain a pure sample, I suppose. So you don't need to filter it, I guess. Evaporate is all you had to write for the mark. The only word you had to write was evaporate. And if you put in filter the products, then evaporate, then you get the mark for evaporate. You don't lose a mark for filter. If you heat it and evaporate, that you get the mark for evaporate. You don't get the mark for heat. Now remember, when you're doing these graphs, when you have to plot something onto a graph, you get half a box of tolerance from the marker, and when you have to read a graph to get a value off it, you get half a box from the marker of tolerance. So the first thing you had to do is read your volume, and you've got to be careful because every one of these squares is 2 centimeter cubed. So and then we were going to read our volume at 50, so 0 to 50. So you had to make sure you marked off the time, read the volume at time, and it looks like it was 87, so it's crossing between 86 and 88 on this scale. So you would be allowed half a box of tolerance, which is 86, 87, or 88. You could use any of those 3 values. Choose one and do your calculation. Your difference in time is 50 seconds. Your change in quantity is 86 or 87 or 88. I chose 86 in this case. And your answer was 1.72 centimeters cubed per second, or 1.72 centimeters cubed seconds to the minus 1. Now, you do not have to put the unit in, but if you do put the unit in, the best thing to do is choose the one they've given you and make sure you write it out correctly. If you put a per sign in there, centimeters cubed per seconds to the minus 1, that's wrong. You'll lose a mark for that. Okay, and then add a curve to the graph to show the results that would be expected if the experiment was repeated using the same mass of zinc lumps. Remember, in reaction rate, the lumps are going to be a slower reaction than the powder because the powder has a higher surface area, more collisions, etc. So you need a shallower graph, and it has to end at the same place. Ends at the same place. Right. Similar experiment was carried out using the same mass of zinc powder and the same volume and concentration of hydrochloric acid. Now, this is the question where everybody stumbled. Remember, the volume and concentration is going to be a molar concentration. Okay, so you're going to have the same number of moles of hydrochloric acid as you have sulfuric acid in the reaction. Okay, but the hydrochloric acid has only 1 mole of hydrogen per mole of the substance formula, whereas sulfuric acid has 2 moles of hydrogen per mole of the substance formula. So if you do this reaction, you're going to get half the amount of hydrogen gas. And this is what we're measuring up here, the volume of gas produced. So you get half the amount of hydrogen gas. Therefore, you just take the total of the gas you got from the previous reaction and divide it by 2. And you'll get 48 centimeters cubed of hydrogen gas. Again, don't put the unit in if you don't need to. And you don't need to in this. 1 mark questions, you'll never have to put the unit in for a 1 mark question at National 5. So just write 48 and you're done. Also watch out for another little problem that many students fall foul of, is what they do is they take the number from the previous question, the volume from the previous question, and use it down in this question. Now that would be incorrect because they're talking about how much was produced in the whole reaction, which was 96, not how much was produced in the first 50 seconds, which was 86 or 87 or 88, which is what you got. But it's very tempting because you've already looked at the graph to grab this number and use it in this question, but you'll not get the mark for that. So watch out for that. We normally get half a box tolerance for getting a value off a graph, but in this particular case, because the line has been on 96 and it sits on 96 for, 20 seconds, you don't get half a box of tolerance there. You've got to read 96 off the graph and put it into your answer. 48 centimeter cubed was the only answer that was acceptable for that question. Okay.